Hello YouTubers, it's me again, and in this video I'm going to be showing you how to prove that the area of an equilateral triangle, that is a triangle that has equal lengths on each side, is equal to a squared times root 3 over 4. This is official, by the way. Google gives you the same result. If you search for the area of an equilateral triangle, that is what you'll find. Anyway, let's get started. Okay, so I'm going to begin by telling you what this diagram over here actually is. What I've done is drawn a straight line across like this, and then I've created a circle with the center on this point, this blue point over here. So I've created a circle around that point, okay? Now where this circle over here, where its edge touches this line over here, I created another circle with exactly the same radius, okay? So this circle here to the left is exactly the same in size as this circle over here to the right. But this circle over here to the right is obviously on the right. This is going to mean, because of this diagram, this is going to mean that from this point over here in blue to this point over here, you're going to have a radius. And we're going to give the value of that radius a, okay? From here to here, right, we also have a radius, and we are going to give it the same value a. And from here to here, we also have a radius, and we are going to give it the same value a. And as you can see, if we do that, what we'll have is, let me see if I can just draw the line here. Whoops. If we do that, what we'll get, right, is an equilateral triangle. Okay, a perfect equilateral triangle. This is true in geometry. You know, this is pure geometry here. This is what we get. So just going to create that line over here, and I'm going to give these lengths over here the value a, okay? These are all a. So from here to here you have a, from here to here you have a, and from here to here you also have the length a. We've got our equilateral triangle. Okay, so we've got our diagram of the equilateral triangle, but at the moment it isn't really fit for purpose. In other words, it's not ready for us to make a proof. To make a proof, we're going to need to add something to this diagram. And what we are going to add, okay, is a line, a straight line, completely straight line from the apex of this equilateral triangle to its base over here, okay? This means that we are going to get a right angle of 90 degrees over here, and equally we are going to get a right angle of 90 degrees over here, okay? Now, in order to get the area of this equilateral triangle, we will need to name this height from the apex of this equilateral triangle to its base h, okay? We are going to name it h. And we are going to use Pythagoras' theorem to get the value of this area over here that I've put in x, and the value of this area over here that I put in x. Combined, these two areas will give us the area of the equilateral triangle, and we'll end up with our proof and this equation over here in the top right hand corner. Now, this value of h over here needs to be written down in terms of a, right? So we can have a nice and neat equation like the one in the top right hand corner. You know, having two variables in the equation isn't very good. So we want to have h in terms of a, so that we get this equation in the top right hand corner. And in order to get that value of h in terms of a, we will require Pythagoras' theorem, okay? And I'm going to demonstrate how this is going to work. This line from the apex of the equilateral triangle, which touches the base of the equilateral triangle right over here, is splitting the equilateral triangle in two. This length at the bottom is a, so if we split it in two, what do you think we're going to get? We are going to get the value half a, okay? If we split this length from here to here in two, we are going to get the value half a, okay? And we know, because of Pythagoras' theorem, that half a squared, okay, plus h squared is going to be equal to a squared over here, okay? So that's half a squared plus h squared is going to be equal to a squared because of Pythagoras' theorem. Let's write this down. So half a squared plus h squared is going to be equal to a squared. Now with this equation over here, we can determine the value of h in terms of a. Okay, so our next task is to manipulate this equation over here and to get the value of h in terms of a. So let's do this. What is half a squared? Well, that's going to be a squared over 4, okay? And we get plus h squared over here. And that is going to be equal to a squared. Now a squared is the same as 4a squared over 4, because 4 over 4 is obviously equal to 1. So this means we get h squared is equal to 4a squared over 4 minus a squared over 4, because we've subtracted a squared over 4 from both sides of the equation. Now, if we have this, we end up with h squared is equal to 3a squared over 4. Okay? Now, because we've got h squared on the left-hand side of the equation, h is going to be equal to positive root 3a squared over root 4. Okay, and this is the same as h is equal to root a squared multiplied by root 3 over 2. And this is equivalent to, because root a squared is actually a, h, let me delete this, h is equal to a multiplied by root 3 over 2. Okay, so this over here is the value of h. We found h in terms of a, and we are going to use this value in order to get this lovely and tidy equation in the top right hand corner over here. Okay, so we're getting closer to completing this proof. We've established that h is equal to a multiplied by root 3 over 2. Now the next task is to find the area of half of this equilateral triangle, shaded in green. If we find this area, we can then multiply it by 2 to find the area of the whole equilateral triangle. This is because this side, shaded in green, okay, is equivalent to this side, shaded in blue. They have the same lengths and they are both right-angled triangles. Okay, so how do we get the area of half of this equilateral triangle? Well, what we can do is put a rectangle on it like this, outlined in red. We get the area of this rectangle and then divide it by 2 to get the area shaded in green, because it is obviously half the area of the rectangle. Now the area of the whole rectangle is going to be half A, this length down here, times the height, which we've established in terms of A. So without any further complications, let's find the area of half of this equilateral triangle shaded in green. We are going to say that half of the area of the equilateral triangle is equal to half A multiplied by H divided by 2. Now this is equal to a quarter multiplied by A multiplied by H. However, we know that H is equal to A multiplied by root 3 over 2. This means that half the area of the equilateral triangle is equal to 1/8 times A squared times root 3. Look at the smile on my face. I know that I am that close to completing this proof. Gosh, it's been a journey. Anyway, the next step now is to multiply the area of half of this equilateral triangle by 2. If we do this, we're going to get the area of the whole equilateral triangle, and we get our proof. Let's do this. As you can see, the area in green is equivalent to the area in blue, so we just double the area in green to get the whole area of the equilateral triangle. We do this by saying that 2 times half of the area of the equilateral triangle is 2 times 1/8 multiplied by A squared multiplied by root 3. And this leaves us with a quarter multiplied by A squared multiplied by root 3, which is the entire area of the equilateral triangle. And this result over here can be found on Google. If you search for the area of an equilateral triangle on Google, you're going to find this formula right over here. If you like my work and you like what I do, be sure to follow me on Instagram, subscribe to my YouTube channel, and for now I'm going to say bye. It's been a pleasure helping you out with another proof.